Hello everyone, my name is Kishan Agarwal. Today I'm going to present my research-based learning project, and the title is Enhancing Blockchain-Based E-Voting Systems with Privacy-Preserving Mechanisms and Scalability Improvements. And my team member is Sai Chandra. So let's begin with the topic. Building a secure electronic voting system that offers the fairness and privacy of current voting schemes while providing the transparency and flexibility offered by the electronic systems has been a challenge for a long time. So in this paperwork, we evaluated an application of blockchain as a service to implement distributed electronic voting systems. The proposes a novel electronic voting system based on blockchain that addresses some of the limitations in existing systems and evaluates some of the popular blockchain frameworks for the purpose of constructing a blockchain-based e-voting system. In particular, we have evaluated the potential of distributed ledger technology through the description of case study, namely the process of an election and the implementation of a blockchain-based application which improves the security and decreases the cost of hosting a nationwide election. Introduction. Electronic voting systems have been the subject of research for decades, aiming to reduce the cost of running an election while ensuring the election integrity by meeting security, privacy, and compilation required. Transitioning from traditional pen and paper method to new electronic systems can minimize fraud and make the voting process traceable and verifiable. Blockchain, a distributed, immutable, and inconvertible public ledger, offers three key features. First of all, immutability. Immutability, that is, each new block in the ledger must reference the previous version, creating an unchangeable change that prevents tampering. Verifiability, the decentralized replicated ledger is distributed across multiple locations, ensuring high availability and providing third-party verifiability as all nodes maintains the consensus version of ledger. Distributed consensus, a protocol requiring the majority of network nodes to reach consensus before appending new transactions to the ledger, thus ensuring the security. So these are the three important methods which are provided by the blockchain. So these features are achieved through advanced cryptography to encrypt and decrypt the usernames or whatever. If we are doing Aadhaar based voting, then that numbers are encrypted, provided a higher level of security than previous record keeping systems, making blockchain a substantial tool for modern voting process. The problem statement which we are going to discuss is developing a secure electronic voting system that upholds the fairness and privacy of traditional voting methods while incorporating the transparency and flexibility of electronic system. So as this is a research-based project, we are evaluating the application of blockchain technology to implement a distributed electronic voting system that addresses security, privacy, transparency, and cost issues in existing systems. Solution. What the solution which we are providing is uh, blockchain setup, a Go Ethereum permissioned proof of authority POA blockchain is used to ensure privacy and security requirements for e-voting. This setup prevents covert voting and ensures voters cast their votes in a supervised environment. Voter registration and authentication. Voter registration is handled by election administrators who authenticate and authorize eligible voters using government verification services. Each voter receives a unique identity wallet for each election they are eligible to participate in. And that wallet is then evaluated for the election results. Framework evaluation. The solution evaluates three blockchain frameworks, Exonum, Quantum, and Go Ethereum, based on their capabilities, consensus mechanism, transaction support, and programming languages. Go Ethereum is chosen for its developer-friendly environment and robust support for smart contracts. Existing systems. So we'll discuss some of the existing systems. That is DRE, Directed Recording Electronic Voting Machines. These machines directly record votes electronically. They may have touchscreen interface and store voters internally or transmit them securely through center systems. Internet voting, that is, allow voters to cast their ballot remotely using the internet. This method often involves strong encryption and authentication to ensure the security. Next is mobile voting apps. Some jurisdictions have experimented with mobile apps that allow voters to securely cast their vote from their smartphones, but these typically use encryption and authentication protocols. Next is blockchain-based voting. It utilizes blockchain technology to create a decentralized and secure ledger of votes. This can enhance transparency and integrity by allowing all holders to verify the results. Biometric authentication. Some systems uses biometric data like fingerprints or iris scans for voter authentication, adding an extra layer of security. So what is our proposed system? It contains smart contracts and privacy measures. Smart contract creation involves three steps, that is election creation, voter registration, voter verification, and then voting process, vote verification. Next comes privacy and security measures, which involves permission, blockchain, proof of authority, and supervised voting environment. Now, results and outcomes. Evaluation of blockchain frameworks. We are going to evaluate and then comparing the three blockchain frameworks. First is Exonum, Quorum, Go Ethereum. Exonum, which provides us with high performance and security, which is not widely adopted for large scale public use, which can be used for the elections which are on a small scale, like bank elections or any community elections which are held on small scales, whereas Quorum based on Ethereum offering privacy and performance. This is complex to set up and limited scalability. That means we cannot increase the number of voters or number of candidates as much as possible. There is a limit on that. And next is Go Ethereum, that is popularly called as Get, which is a very popular and mature platform. It is most preferably chosen for its balance of security, scalability, and ease of use, which is this web is easy to use. That means it has user-friendly environment and scalability. This is the very important feature of web, which provides you to increase and increase the number of voters and also the candidates participating in it. So it is very scalable. Next comes the security. Security, it provides best security, like encrypting and decrypting the transactions at each and every level. So that's why this is very popularly used. So these were the three blockchain frameworks which are generally used, and we are going to use the Go Ethereum. So as discussed, we have proposed a solution for electronic voting based on blockchain that offers transformative solution to the challenges of traditional voting methods by leveraging blockchain's immutability. That is immutability, which we have already discussed. Once the user is created or once the details are being filled, that means a voter votes for some particular candidate, it cannot be muted. That means it cannot be changed. So this is a very much useful feature to expel the tampering of votes which are done in the elections which are done by ballot papers or some other technique which are generally preferred to use. Next is verifiability. Verifiability is very important because during voting, it is must to verify the voter with some unique ID. For example, say Aadhaar card or some voter ID card and distributed consensus. Next is utilizing a permissioned blockchain with proof of authority consensus and smart contracts for election management. The system ensures secure, transparent, and efficient voting. There's no something called as black box. It is transparent. That means open source. You can easily check all the contracts. Then comes the addition of supervised voting environment that prevents correction and fraud, maintaining election integrity. This innovative approach not only enhances voter privacy and trust, but also provides a scalable, cost-efficient method for conducting elections, marking a significant advancement in democratization process. These are future work related to our topic. That means improving the privacy preserving techniques such as zero knowledge proofs or enhanced voter anonymity, advanced cryptographic methods. As we can say that cryptographic methods are insane research topic. So as the advancement in cryptographic methods, we can advance in these blockchain methodologies and then scalability solutions, real world pilot tests, legal and regularity frameworks. Thank you.